Right now, as you listen to this, you are navigating, well, an endless labyrinth of choices.
Yeah, thousands of them.
Exactly. Some are incredibly deliberate, like deciding to switch careers or choosing a new city to live in.
Right, the big ones.
But others are so microscopic they barely even register as conscious thought. Like you decide to take a sip of coffee, or you choose to linger at a stoplight for just an extra half second.
Just tiny, almost automatic deviations in your routine.
Yeah. And we spend our entire lives operating under this one single fundamental assumption, which is that we are navigating one solitary timeline.
Right, the idea that you make a choice, and that choice steers your one physical life down a singular path.
And all the other possibilities are just left behind as, I don't know, ghosts of the imagination. But today, I want to invite you to look at those microscopic decisions through a completely different lens.
A radically different lens.
What if the universe doesn't actually force you to choose? What if, at the most fundamental level of reality, every single physically possible outcome of every single decision is not just a hypothetical, but a literal physical reality?
Which is just a massive thing to try and wrap your head around.
It really is. We are talking about a framework where every time a quantum event occurs in your brain, or even just in the environment around you, reality itself fractures.
Yeah, literally creating a brand new, completely physical universe running in parallel to the one you currently occupy.
It is an incredibly disorienting concept to sit with. And, because of pop culture and movies, it is very easy to instinctively categorize this idea alongside, like, time-traveling DeLoreans or comic book multiverses.
Absolutely. But the crucial grounding point for our exploration today is that this concept, this proposition of an ever-branching universe, it was not born from science fiction.
Right.
It was born from cold, hard mathematics. It is an entirely serious, intensely debated attempt to solve a very real and glaring gap in our understanding of modern physics.
So we're going to be exploring territories that completely defy everyday human intuition. But this isn't fantasy.
No, not at all. It is a proposed mechanical solution to a problem that has frustrated, honestly, the brightest minds in the scientific community for nearly a century.
And we should probably establish a firm boundary right at the outset here. Absolutely nothing we are going to explore today is definitively proven.
Right, that's so important. We are examining an open, highly contested debate at the absolute frontier of theoretical physics. Neither of us has the ultimate answer here.
Exactly. Okay, let's unpack this. That sets the exact parameters for our mission in this deep dive. We are looking at the most successful scientific framework ever devised, which is quantum mechanics.
Yeah, a framework whose predictive accuracy is so astonishingly precise that it makes our entire modern technological civilization possible.
Right, like lasers, computer chips, all of it. Yet, sitting right at the absolute center of this magnificent, hyper-accurate theory is a black box.
An incredibly frustrating black box.
Right. An unsolved mystery regarding what physically occurs when we observe or measure a system.
Because the specific mechanical answer to that single question dictates whether you are currently living in one isolated universe or if you are riding just one branch of an infinitely expanding cosmic tree.
So, to truly dissect that black box, we have to establish the baseline of how reality operates before a measurement ever takes place, right?
Yeah, let's start there. If we look at the microscopic world, the objects around us have definite states.
Like the microphone in front of me is occupying a specific coordinate in space. It is not simultaneously hovering near the ceiling and sitting on the desk.
Exactly. It's just right there. But when we zoom down to the fundamental building blocks of reality, like the subatomic level, the mathematical equations that govern those particles tell a fundamentally different story.
They really do. Before a particle interacts with a measuring device, it does not possess a single definitive state or location.
No, it exists in a condition of multiple superimposed states.
And this concept, this idea of superposition, is frequently glossed over, so we should really look at the actual mechanics of it.
Yeah, because it isn't just a matter of human ignorance.
Right. It isn't a scenario where the particle actually is in one specific place, and we simply lack the instruments to know which one it is.
The mathematics, specifically the wave equations governing the system, describe the particle as existing as a literal combination of all possible states simultaneously.
It's like a wave of pure probability. If we think about a classic setup, like firing a single electron at a barrier with two microscopic slits.
Yeah, the famous two-slit setup.
Right. The math doesn't say the electron goes through the left slit or the right slit. It says the electron's wave function passes through both slits simultaneously. interfering with itself on the other side.
And the physical reality of that interference pattern is the undeniable proof of superposition.
Right. We can literally see the pattern it makes.
Exactly. When we don't measure which slit the particle goes through, the mathematical description of the wave perfectly, flawlessly predicts the resulting interference pattern we see on the detector screen.
The wave function, which represents this vast smear of probabilities, it evolves forward in time smoothly, deterministically, and continuously.
Yeah, there is no randomness in how the wave behaves at this stage. It operates strictly according to a foundational equation that dictates exactly how these probabilities shift and flow.
But the smooth, deterministic flow of that wave's equation crashes headfirst into the central paradox of our deep dive. The measurement problem.
A big wall we hit.
Yeah. Because the moment we place a detector at the slits, like the absolute millisecond we demand to know the specific location of that electron, the interference pattern vanishes.
It just disappears.
We never observe a smear of probabilities. We never look through a microscope and see an electron existing in 3 places at once.
No, the instant we measure the system, we find a single, solid particle in one definitive location.
And the transition you are describing is the absolute crux of the crisis.
It really is. The wave function containing all those multitudes of overlapping possibilities suddenly and violently reduces to a single definite outcome.
And the crazy part is, the mathematical framework we use to describe the smooth evolution of the wave contains absolutely no mechanism for this sudden reduction.
None at all. The equations just keep evolving the wave indefinitely.
Right. So to make the mathematics match our physical reality, where we only ever see one outcome, physicists had to manually staple a new rule onto the theory.
Yeah, a completely arbitrary patch. They had to postulate that the act of measurement causes the wave to collapse.
And the introduction of that manual patch, this collapse postulate, is where the logic of the universe seems to short-circuit entirely for me.
It does feel like a cheat code.
Let's look at the famous thought experiment from the 1930s involving the cat in the box, because it illustrates perfectly how this bizarre subatomic behavior infects the macroscopic world.
Oh, this is the perfect example.
So we place a cat in a sealed steel chamber. Alongside the cat, we place a device containing a single radioactive atom.
And we set it up so there is an exact 50% chance the atom will decay within 1 hour.
Right. If it decays, it triggers a mechanism that shatters a vial of poison, killing the cat. If it does not decay, the vial remains intact and the cat continues to live.
The brilliance of that specific thought experiment lies in how it links the quantum world directly to our everyday reality.
Yeah, the macroscopic stuff.
Exactly. The radioactive atom is a quantum system. Before we open the box to measure it, the unmeasured atom exists in a superposition of both decayed and not decayed states simultaneously.
But the setup inextricably links the macroscopic device, the hammer, the vial, and the biological system of the cat, to that single quantum state.
Which means the mathematics governing the box describe the entire system as entering a superposition.
So the atom is decayed and undecayed. Therefore, the hammer has both dropped and not dropped.
The vial is shattered and whole.
And the cat, well, is simultaneously alive and dead. The wave function of the entire box contains both distinct macroscopic realities.
But the collapse postulate tells us that the second a human being unseals the box and looks inside, that sprawling wave function violently collapses.
It instantly deletes one reality and crystallizes the other.
Right. And the core intent of that historical thought experiment was actually to demonstrate the absurdity of the collapse postulate.
It was meant to show that the mathematics cannot simply be halted by human observation.
Exactly. And yet, decades later, that absurdity remains unresolved. The collapse requires us to accept that the physical universe undergoes a radical, instantaneous transformation simply because it is being measured.
See, I look at the sheer mechanics of that, and the logic simply evaporates. I find it so incredibly frustrating.
Oh, I find it fascinating, but I totally get the frustration.
If the collapse is a real physical event, what triggers it? How does the universe define a measurement?
Right, what's the threshold?
Reality cannot possibly pause its own fundamental rules and wait for a human retina to capture a photon. Does the universe care if a conscious mind is processing the data?
That's the boundary problem. If we put a digital camera inside the box instead of a human observer, does the hard drive record a superposition, or does the camera's lens trigger the collapse?
What if a bacterium interacts with the radioactive atom? Does a single-celled organism have enough observational power to force reality to choose a path?
And those unanswerable questions just highlight the severity of the gap.
It's massive.
We possess a scientific theory that engineered the silicon chips in our computers and the lasers in our medical equipment. It is the bedrock of modern civilization.
And yet, at the dead center of the theory, we essentially have a placeholder that says, a miracle occurs here.
Yeah, we have no physical threshold for what constitutes an observer, and we have absolutely no mathematical mechanism for how a wave of infinite possibilities instantaneously vanishes across space to leave a single particle behind.
We have a theory that perfectly describes reality when we look away, and perfectly predicts reality after we look, but it just completely breaks down in the intervening millisecond.
We are stuck with a magical, undefined boundary.
Which opens the door to an idea so radical that it attempts to solve the paradox by simply throwing the boundary away.
Right, because if the mathematical discontinuity of the collapse is the source of all these logical contradictions, a subset of physicists proposed a remarkably dangerous and mathematically elegant solution.
Which is, what happens if we simply erase the collapse from the equations entirely?
Exactly. What if we trust the underlying wave equation completely, without adding any manual patches or exceptions for human observation?
If we follow that logic, we arrive at the proposal that forms the heart of our exploration. If you delete the collapse postulate, the wave function never stops evolving.
It never suddenly reduces to a single point.
It remains a superposition forever. So in the scenario of the sealed box, the act of opening the lid does not force the universe to choose between a live cat and a dead cat.
No, instead, the mathematics suggests that all the outcomes contained within the wave function actually happen.
Every single possibility is fully realized.
And that is the foundation of what is commonly described as the many worlds interpretation. It resolves the measurement problem by suggesting the universe itself physically branches.
So when the observer opens the box, they don't force reality to collapse.
Right, rather the observer becomes entangled with the superposition. The universe splits into two distinct, non-interacting realities.
Let's visualize the physical mechanics of that branching, because it's wild.
Yeah.
In one perfectly real physical universe, an observer opens the box, sees a live cat, and feels relief.
Yeah.
In a newly branched, equally real, totally separate physical universe, an identical version of that observer opens the box, sees a dead cat, and feels grief.
Both universes contain physical matter. Both contain conscious observers experiencing a singular reality.
You, the listener, simply experience the subjective reality of the branch you happen to be occupying, utterly isolated from the other.
The appeal of this framework to certain theoretical physicists really cannot be overstated because it restores a beautiful mathematical purity to the universe.
It cleans up the math.
Exactly. It regains strict determinism. In the traditional collapse view, the universe is fundamentally random.
The outcome of a quantum measurement is a roll of the cosmic dice. We can predict the odds, but we can never predict the specific result.
But in a branching framework, God does not play dice. There is no randomness. Everything that the wave function says can physically happen absolutely does happen.
The underlying mathematics of reality remain smooth, unbroken, and logically consistent from the subatomic level all the way to the scale of the entire cosmos.
And we see continuous, rigorous attempts to map out the exact mechanics of this process.
Yeah, I was actually looking deeply into some theoretical work published just recently in January of 2026.
Oh, the emergence papers.
Right. Certain researchers were exploring the specific mechanisms of how our incredibly stable, classical, macroscopic reality could mathematically emerge from a universe that is splitting and fracturing billions of times every microsecond.
Because that's a huge question. If we are riding a wave of infinite possibilities, why does our reality feel so singular and concrete?
Exactly. They are tackling that exact paradox.
And the mechanism those January 2026 papers focus on is a process known as decoherence.
Right, decoherence.
To understand decoherence, you have to realize that no quantum system is ever truly isolated. An atom or an electron is constantly being bombarded by the surrounding environment.
Stray photons bouncing off it, molecules of air interacting with it.
Exactly. When a quantum system in a superposition interacts with its environment, it becomes entangled with that environment.
The superposition basically leaks out. The delicate quantum state of the particle bleeds into the surrounding room, to the measuring device, into the air itself.
And as that entanglement spreads at the speed of light, the distinct states, the live cat state and the dead cat state, lose the ability to interfere with one another.
The mathematical phase relationship that held them together diffuses into the background radiation of the universe, effectively sealing the branches off from each other permanently.
And that leakage of phase information happens incredibly fast. For a macroscopic object, decoherence occurs in a tiny, tiny fraction of a second.
And the mathematical models suggest that this environmental interaction is what gives the illusion of a collapse.
Right? The wave didn't vanish. The distinct branches simply became orthogonal to one another, meaning they can no longer interact mathematically or physically.
The universe seamlessly unzips itself into parallel tracks. I gotta say, the philosophical implications of that unzipping process are staggering.
They really are.
I try to remain objective, but the science fiction implications inevitably pull at the imagination. Because if every quantum interaction in my brain, every slight variation in the firing of my neurons, creates a physical branch in reality. It means there is a branch where I chose not to record this deep dive today. There is a branch where I turned left instead of right a decade ago and entirely rewrote the trajectory of my life.
The sheer scale of infinite permutation is totally intoxicating.
It really is.
But can we ever actually test that?
And there's the gravitational pull bringing us straight back to the Earth. The demand for empirical verification.
It is the single most vital question in this entire debate. If we are asserting that these infinite branches are physically real, made of actual energy and matter, we have to demand a physical explanation for their mechanics.
Like if an electron in a laboratory in Tokyo enters a superposition and branches, does the entire physical cosmos from Earth to the Andromeda Galaxy instantaneously duplicate itself?
Right. Does branching happen at infinite speed, completely violating the cosmic speed limit of light?
The logistics of the branching process are mind-bending. Where do these physical universes reside? They clearly aren't expanding out into our three-dimensional space.
No, the mathematical framework suggests they exist in Hilbert space, which is an abstract, infinite-dimensional mathematical space where quantum states live.
But mapping a mathematical abstraction directly onto physical reality requires massive leaps of faith.
We must also consider the sheer volume of creation. If every single quantum event everywhere in the observable universe causes a branching of reality, the multiplicity is incomprehensible.
Trillions of quantum interactions occur in a single drop of water every nanosecond.
Exactly. The rate at which these parallel universes would be generated is so aggressively massive that human language lacks the terminology to describe the number.
And if the branches are fundamentally cut off from one another through decoherence, if no signal, no photon, no gravitational wave can ever cross the divide from one branch to another,
then we are entirely cut off from empirical observation.
Right. We can never build an instrument to detect the branch where the cat died.
Which brings a severe critique from the scientific community. If a theory posits the existence of infinite physical entities that can never in principle be observed or interacted with, is it still physics?
Or has it crossed the boundary into metaphysical philosophy, shielded forever from the rigorous demands of the scientific method?
That critique serves as the perfect pivot point for us. Because while the branching universe elegantly solves the measurement problem on paper, the sheer weight of what it demands we accept has created fierce opposition.
Let's dig deeply into the serious objections to this idea, starting with a profound mathematical puzzle known as the preferred basis problem.
The preferred basis problem asks a devastatingly simple question. What precisely dictates the boundary lines of a branch?
Right, because the mathematics of quantum mechanics are incredibly flexible.
Yeah, the state of a system can be written in many different mathematical bases, much like you can describe a location using latitude and longitude or using distance and direction.
To use a physical analogy, imagine the universe as an enormous block of marble. The mathematics of the branching theory say that reality must be carved into distinct slices, creating the separate universes.
But the raw equations of quantum mechanics do not come with instructions on where to place the chisel.
Exactly. Why does the universe choose to carve the marble along the lines of things humans recognize?
Why does it split perfectly into a universe with a live cat and a universe with a dead cat?
Why does it split into abstract, unidentifiable quantum smears that have no macroscopic equivalent?
Well, proponents of the theory argue that the environment itself dictates the slice.
Right. The decoherence we talked about.
Yes, the mechanism of decoherence naturally favors states that are stable in the presence of environmental interaction states, like definite positions and definitive macroscopic arrangements.
But many theoretical physicists argue that relying on the environment to select the preferred basis is logically circular.
It assumes the existence of the very macroscopic properties it is trying to explain.
It doesn't fully explain why the fundamental fabric of reality must carve itself up into neatly packaged, human-comprehensible storylines.
But, the preferred basis problem is almost a minor technicality compared to the absolute leviathan of an objection waiting next.
Oh yeah, the probability problem. Because if you want to replace the standard view of quantum mechanics, your new theory still has to successfully account for the predictive power of the original math.
And the original math is entirely built on predicting probabilities. Let us examine the mechanics of probability in the standard framework.
Okay.
The wave function assigns different mathematical weights, called amplitudes, to different possible outcomes. If we fire a photon at a polarized filter, the math might tell us there is a 90% probability the photon passes through and a 10% probability it is blocked.
Right, and if we run that experiment 10,000 times in a laboratory, the physical results perfectly mirror the math.
9,000 photons pass through, 1,000 are blocked. It is an incredibly reliable, empirically verified rule of reality.
Now, we take that reliable 90-10 probability and try to force it into the branching universe framework.
And it gets messy.
Very messy. In the branching model, the universe splits. In one physical branch, the photon passes through. In the second physical branch, the photon is blocked.
Both outcomes occur. Both branches are equally real. Both contain an observer writing down a result.
So if every outcome happens exactly 100% of the time in some branch, the entire concept of probability becomes meaningless.
Exactly. If all possible branches are realized, why does the observer in our universe experience the highly probable outcomes far more often than the improbable ones?
If you buy a lottery ticket and the universe branches to create a reality where you win and a reality where you lose, the you in the winning branch feels just as vividly real as the you in the losing branch.
How can a theory where literally everything happens simultaneously manage to derive the strict, uneven statistical probabilities that we observe in our laboratories every day?
It is a devastating logical knot. And the research attempting to untangle it often seems to create even more paradoxes.
Oh, tell me about it.
I was analyzing a paper from August 2025 where some researchers argue that the branching interpretation contains an inherent, inescapable logical paradox regarding self-location.
The self-location paradox.
Yeah. They suggest that if you are a conscious observer constantly branching into infinite copies of yourself, your ability to rationally deduce anything about the underlying universe collapses.
The paradox they highlight revolves around epistemic certainty. If infinite versions of you exist, experiencing every possible statistical anomaly, then there is a branch out there where a scientist flips a quantum coin 10 million times, and it lands on heads every single time.
Which is statistically absurd, but physically possible.
Right. And in that specific branch, the scientist would look at their data, conclude that the laws of physics are entirely broken, and publish a deeply flawed theory of the universe.
The terrifying implication of that August 2025 paper is that if the branching theory is correct, we have absolutely no way of knowing whether we are currently living in a normal branch that accurately reflects the underlying math.
Or if we are living in a bizarre outlier branch where our past experiments were just massive statistical flukes.
It eats its own tail. By trying to make the universe perfectly deterministic, the theory fundamentally undermines our ability to trust our own scientific observations.
And the probability debate continues to intensify. Certain mathematical approaches published in February 2026 attempted to apply rigorous statistical mechanics to the branching model.
I read about those. They utilize ergodic theory, right?
Yes. Ergodic theory is a branch of mathematics that studies the long-term statistical behavior of dynamic systems. They mapped the continuous evolution of the wave function across infinite parallel branches.
And the conclusion of applying that ergodic math was startling.
Oh, it really was.
It suggests that when you track the sheer volume of infinite branches over time, the statistical weight of the normal branches, branches that obey the probabilities we see in our labs, approaches zero.
The researchers propose that if the branching model is literal reality, the standard probability rules we rely on to build our technology would actually break down in almost all of the parallel branches.
The orderly universe we experience would not just be one path among many. It would be an astronomical anomaly amidst a sea of thermodynamic chaos.
Which forces us to confront the ultimate philosophical barrier, which is the ontological cost of the theory.
Right, ontology. The philosophical study of what entities exist in reality.
And a guiding principle in science is that we should not postulate the existence of unobservable, untestable entities unless absolutely forced to do so. We seek the simplest mathematical explanation that matches the physical data.
And just to put the ontological cost in perspective here, We are trying to explain why a single mathematical equation, the wave function, needs a sudden jump when we measure a particle.
Yeah.
To avoid writing a new equation to explain that jump, the branching theory demands that we accept the physical creation of trillions of new entire universes every second, constantly expanding into an unobservable infinite dimension forever.
It requires generating more physical mass, energy, and unobservable space in a single microsecond than humans have previously conceived of existing in the entire cosmos.
It's just staggering. Is this explosive multiplication of reality a beautiful revelation of the true nature of existence, exposing our previous universe as just a tiny sliver of a grander structure?
Or is it the ultimate sign of a mathematical model stretched past the breaking point? Does an insistence on preserving the purity of an equation justify inventing an infinite number of undetectable realities?
The sheer weight of those objections really forces us to survey the rest of the landscape. Because if the branching universe demands too high a logical price, we have to find another way to resolve the measurement problem.
We have to look at the competing answers.
Right. We must establish clearly what the alternative models demand of us, because honestly, none of them offer a comforting, intuitive reality.
No, they don't. Let us return to the first alternative, the traditional framework most commonly taught in universities.
The collapse view.
Right. The premise that the physical act of measurement genuinely causes a sudden, discontinuous collapse of the wave function.
So the wave of possibilities is not physically real.
Exactly. It is merely a tool to calculate probabilities, and reality only solidifies when a macroscopic measuring device interacts with the quantum system.
Now, pragmatically, I find this approach deeply appealing.
Really? Why?
Because it aligns seamlessly with human experience. When I interact with my environment, I don't encounter sneering probabilities, I encounter solid objects.
Fair point.
This framework allows engineers and physicists to treat the quantum world as a black box of statistics that miraculously spits out concrete answers when we poke it.
It is incredibly functional for engineering.
Right. It allows us to calculate the necessary voltages for semiconductors without worrying about parallel dimensions. It gets the job done.
It is highly functional, but theoretically, it remains deeply unsatisfying for fundamental physics.
As we explored with the cat experiment, the fatal flaw of this interpretation is the Heisenberg cut. The invisible, undefined boundary between the quantum system being measured and the classical system doing the measuring.
Exactly. If the measuring device forces the collapse, what exactly defines the device? A Geiger counter is made of atoms.
And those atoms are governed by quantum mechanics. So why doesn't the Geiger counter enter a superposition?
If we place a human observer in the loop, we hit a wall of mysticism. Does human consciousness possess some unique physical property that forces reality to crystallize?
This interpretation demands that measurement is a fundamental physical force of nature, yet it cannot provide a single equation defining what that force is or at what mass threshold it activates.
So if we reject that, we move to the second major alternative, a framework that attempts to restore absolute classical realism to the quantum world.
We can conceptualize this as the invisible guide model.
Yeah, that's a good way to frame it. In this framework, particles never exist in a smear of probabilities. There is no superposition of physical matter.
A particle, like an electron, is always a tiny solid object with a definitive exact coordinate in space at all times, whether we are looking at it or not.
And that immediately solves the measurement problem. If the particle is always in one exact location, there is no need for a magical collapse when we observe it.
We simply discover where it was all along. But to explain why the particle moves in such bizarre, wave-like patterns like in the double-slit experiment, this theory introduces a new mathematical mechanism.
It proposes a real physical wave that permeates the entire universe, invisible and undetectable.
The solid particle rides this wave like a piece of driftwood carried by an ocean current. The wave flows through both slits, interferes with itself, and physically pushes the solid particle along a specific trajectory to the screen.
The elegance of this model is its absolute determinism. Reality is solid, grounded, and mechanical.
But its fatal flaw is the sheer extremity of how the invisible waves must operate to match our quantum experiments.
Right. The mathematics dictate that the guiding wave must be universally connected in real time. This implies a property called non-locality.
To visualize non-locality, imagine if two particles are entangled, and one is in a laboratory in New York, while the other is on a rover on Mars. Altering the particle in New York must instantly, with zero time delay, alter the invisible wave guiding the particle on Mars.
The wave must update itself instantaneously across the entire cosmos, vastly exceeding the speed of light.
Furthermore, the theory explicitly states that while the guiding wave controls the particles, the wave itself is fundamentally shielded from our direct observation.
We are asked to accept an invisible, faster-than-light universal framework that secretly puppeteers the solid matter of our universe, but which fundamentally prevents us from ever utilizing its faster-than-light properties.
It forces the universe to operate through a hidden, inaccessible clockwork. I just can't get behind that.
Which brings us to the third major alternative, a framework that abandons both the invisible waves and the parallel universes, and instead asks us to abandon our foundational concept of an objective reality.
We can frame this as relative reality.
In this framework, we strip away the idea of an absolute perspective.
Quantum states, the superpositions, the definitive measurements, the outcomes of experiments, they do not exist as objective facts of the universe.
No, they only exist as relative relationships between interacting physical systems. The state of a particle is not a property of the particle itself. It is entirely relative to the specific observer interacting with it.
The logical progression of this idea leads to scenarios that severely bend the mind. Let's return to the box with the cat.
Okay.
I open the box, I look inside, and I measure the radioactive atom. I record that the atom has decayed. For me, relative to my physical state, the atom has definitively decayed.
Right. But imagine you are standing outside the laboratory. You have not yet interacted with me or the atom.
The mathematics of this interpretation state that relative to you, I have now entered a superposition.
You are simultaneously a researcher who saw a decayed atom and a researcher who saw an intact atom.
The cat is alive relative to itself. It is alive relative to the research in the room. But the entire room remains in a superposition relative to the scientist in the hallway.
Both realities are true simultaneously, depending entirely on which system you're measuring from.
But the fatal flaw here is the philosophical cost. If reality is entirely relational, we must completely surrender the concept of a shared objective universe.
There is no ultimate God's eye view of the cosmos where a definitive history of events exists. There is only my perspective, your perspective, and an endless web of localized relationships.
And so we find ourselves at a total impasse, a magnificent theoretical stalemate.
We really do. We possess the mathematical key to the universe, yet every single doorway it unlocks leads to a reality that our rational minds recoil from.
To answer the simple question of what happens when we look at an atom, you must pledge allegiance to one of four impossibilities.
You embrace an undefined magical boundary where human observation alters the physics of the cosmos.
You accept an invisible, faster-than-light ghost wave that secretly puppeteers solid matter.
You completely abandon the existence of an objective shared reality.
Or you accept the endless, instantaneous generation of infinite parallel universes, splitting off into an unobservable void.
It is a profound demonstration of the limits of our current epoch of science. The greatest minds in theoretical physics have debated these exact pathways for nearly a century without reaching a consensus.
It suggests that our current mathematical tools, while incredibly precise, may be missing a fundamental conceptual piece of the cosmic architecture. We are attempting to describe the ocean using the vocabulary of a desert.
Bringing this massive cosmic debate back down to the human scale, down to the listener currently navigating their day, the implications are intensely personal.
Let's return to the central premise we started with. Let's assume, strictly for the sake of the philosophical exercise, that the branching framework happens to be the true mechanism of reality.
Okay.
If the mathematics of the wave function demand that every physically possible outcome must be realized in some physical branch of the universe, does your individual agency actually exist?
The questions regarding the self and identity become incredibly complex under this framework.
If the universe splits every time a quantum interaction occurs in your neural pathways, infinite iterations of you are being generated every hour.
If there is a branch where an iteration of you successfully navigated every career challenge, and a branch where an iteration of you succumbed to every temptation, who represents the core identity?
Does the concept of you even survive the mathematical shattering of your timeline? Or is you merely an illusion experienced by one single conscious observer riding a singular branch of an infinite tree?
It generates a very specific kind of existential vertigo.
It does. Think about a difficult moral decision you've made in the past. Imagine finding a lost envelope full of cash.
Okay, classic moral dilemma.
You wrestle with the decision, and ultimately you make the moral choice to return it to its owner. You build your sense of self-worth on the foundation of that choice.
But in the branching model, the physical chemistry of your brain simply explored all possible outcomes.
Right. The branch where you kept the money exists just as concretely as the branch where you returned it.
Did you actually exercise moral agency? Or did the physical laws of the universe merely force all possibilities into existence, and you simply happen to be experiencing the subjective consciousness of the iteration that chose the moral path?
And we must openly acknowledge our profound uncertainty regarding these questions. The vertigo you were describing is not just a philosophical reaction,
No, it mirrors the exact intellectual vertigo experienced by the physicists wrestling with these equations.
We are standing at the absolute precipice of empirical science, staring into an abyss that may, due to the fundamental laws of physics, permanently remain beyond the reach of human experimentation.
We may never engineer a device capable of piercing the veil between branches, or detecting the invisible guiding wave, or quantifying the boundary of a collapse.
It leaves us occupying a space where the physical reality of our universe is demonstrably, mathematically stranger than anything we could have intuitively imagined when we woke up this morning.
It absolutely does.
We began this deep dive by examining the microscopic decisions you are making right now as you listen to this. I want to leave you with a final thought to mull over, a concept to sit with as you navigate the rest of your day.
An unresolved tension to carry forward.
Exactly. If the mathematics are literal, and every possible permutation of your life, every massive triumph, every devastating failure, every risk taken, and every opportunity ignored exists as a tangible, physical reality unfolding right now in another branch of a never-ending cosmic tree. Does the single, incredibly fragile trajectory you are currently experiencing matter more? Because it is the only one you will ever know, or less? Because it is just one grain of sand in an infinite desert possibility?